right, friends, as many of you have so astutely noted, yes, this is what you wrote down tomorrow, and that, or tomorrow, yeah, yesterday, which should be in your plan book, because that's what was on the screen. Because that's what was on the screen when you walked in. However, we didn't get to the lesson. At the end of class, I told you today's homework will be tomorrow's. Okay, so if you did it, sweet, awesome, you're ahead, but I still need to cover the lesson to make sure that we're good and we understand all of this. So we may just have a quicker lesson and then have some work time. Your 415 homework, your next one is already up there. It's a larger homework assignment, so you may pick 6 of them to do. I try to keep your homework sets to 6 or less problems, which is crazy to think about, because back in my day of... yeah, it'd be like, here's a worksheet of 30 problems. Do them until you hate them. Yeah, which is part of how math has shifted, right? It's not about how many times can you do this skill. It's about how well can you do this skill to apply it to a situation. So whereas you used to just have a worksheet of just numbers, now you have a book with like story problems, right? Situational problems. So please make sure that you are doing your homework and putting your attention and your respect on that. Hey, Isaac, we'll deal with the rest of that later. You need to get to your next class. Can you do me a favor and not bring that to class anymore? Because if you can't handle it being in class, I had carpet in my room, and I can't have my carpet getting all screwed up. Thank you, bud. The putt is, I think it's just silly putty. I don't even think it's,
Was it pink?
yeah. What? What?
I saw it yesterday.
Thank you, Isaac. So, please make sure you're putting your attention and respect on your homework, because that will directly inform how well you do on the test. I have made a decision that I think is in your favor. The Chapter 2-3 test that we took will be on quarter 2. Just because I would really like all of you to be on Discovery Day and not here. That would be awesome, because we've never gotten every 7th grader out of here. So I decided I would just put less grades in quarter 1, which means, though, when you get it back, which I'll probably give you guys those back like tomorrow or Friday, when you get that back, and you'll likely have it before I even put it in math, because I don't want your parents freaking out or being confused or anything, because if it shows up in math, it'll look like you're not eligible for Discovery Day. What's going on? Do you want to perform for the class or something? Because you're directly stealing Savannah's attention away from me. What did I just say? You even listening? Okay, what did I just say?
Well, so you were talking about how you're going to put less time in math, so like you get like less blessings, like less check minuses, so it doesn't show up that we can't do Discovery Day.
Yeah, so it looks in math, even if I put it on for quarter 2, it looks like you had you'd have a red button because you had a revision, but then it would be a quarter 2 assignment. So like it gets confusing, especially for new parents. So I'm avoiding that by holding off on posting grades and all that good stuff. Gwendolyn, do you want a chair?
No.
You strategically just would rather just kneel? Okay, interesting. So we're going to keep trucking through chapter 4, but then realize a lot of stuff will probably hit math at the same time for math. Sorry, so my train of thought that then got derailed was that once you get it back, do not let it like be back burner, like low priority, like take care of it, because it's very tempting to say, oh, this doesn't matter till next Discovery Day. No, it immediately matters. I'm just like, we could have put it quarter 1 or quarter 2. It was close enough to the break point. I favor putting stuff on the next quarter to make things easier for you.
Thank you.
414, title's really easy. Y equals mx plus b. Y equals mx plus b. And if you want, there's a multiplication in there. Because whenever something is right up against something, it means multiply. So we should all have that header on our paper, please. What did we say yesterday about the m versus the b? And it's okay if you don't remember, because this is still a new part of this. But when we represent rules or patterns or functions, you'll start to hear that word a lot. When we represent these, y equals mx plus b is like our best friend. It is the nice form. So what is the m? George?
The M is the slope or growth.
It is the slope or the growth at each step. And that, one thing I didn't give you yesterday, I don't think, if we want to be formal, I'm going to go ahead and write this up here. M, please write this down. actually equals delta y over delta x. Now, that's Greek. That triangle is actually called delta, but it's a scientific symbol. Mathematics, scientific, whatever you want to say. I don't know who claimed it first, whether it were scientists or mathematicians. But what that means is change. Delta, the triangle, means change. So the change in y, please write this down, is describing the rise, how much it goes up or down. The change in x is what we call the run, how far it goes left or right. You rise vertically, you run horizontally. And then the b value in the equation, y equals mx plus b. Somebody not George. You can get cards if you want to do that. I was just going to see who was paying attention yesterday and wrote it down and internalized it. Teeth, you look like you want to answer. If you don't know it, you can totally pass. You just kind of look like you had it. Okay. Quinn, do you remember from yesterday? Mallory, Savannah, anybody? I'm just picking on people. Yeah, and really the easy way to think about this is our starting value. The technical, which please make sure you have this written down, the technical name for B is the y-intercept. I'm going to rewrite that. So starting value, right? You know, but a lot of people misspell y-intercept. Y, haha, you're funny. Y-inter, and this is where we get through C-E-P-T. It's not intersect, although that's what it does. It intersects, it hits, it meets with the y-axis, but its actual name is y-intercept. Now, what will confuse some people is if I start at that point and only go forward, I don't go through the y-axis, right? I just touch it, I just intercept it. Let's move on. I should have captured that, but sorry, already. Apparently you're not going to work. I'm still holding the pen, that might have been the issue. Alright, so Alicia claims that she can find the equation for this function just by looking at the graph. So my challenge to you as a group, figure out what this function is. What is the m? What is the b? Write it out in the y equals form for this graph. I'll give you like 30 seconds probably. Yeah, that's 4:32. There are 3 things to look at here. Rise, run, intercept. Yeah, let's put people on the spot. Graydon, oh mighty magician. 1 in 22.
And I wasn't ready yet. I'm still figuring it out, but I'll try my best. So
Give me any piece of information.
So in my brain, y equals I'm just using variables mx plus in this case 1 because it started with 1. B equals 1.
So B equals 1.
So that's what I got started with, and then mx. I'm still trying to figure out.
All right, so we'll move on.
It would just be
Just hang on to it. You're good. Gabe, what is my raw? Oh, Gabe, feel better. Gwendolyn, What is the rise going from the first point they give us to the second point they give us? Oh, then you need to get a book. Get a book out. Make sure it's an 8th grade one. Come on. Go ahead. Ooh. So, like, yes, but when so what I was asking was, what's the rise? Rise is 3. So the run is 1. So what you went ahead and jumped over was my m is actually 3 over 1. But what does that reduce to? 3. So our equation just becomes y equals 3x plus 1. The slope, because of this, up of 3 and over of 1 becomes 3, and the intercept is 1. Any questions on that? Try the tape. Oh, sorry, go ahead, George.
Well, you use the, to get this run and the rise, did you get that on any 2 points?
Yep.
Of the line?
Or, check this out. Give me your eyes up here for a moment. If I go from this point all the way to that point, my rise is 6. My run is 2. 6 divided by 2 is 3. Try the table with your group. I'll give you a minute or so to deal with that in 33. Actually, try all 3. We should have rules for all 3. So A, and then BI, and BII. We do not have to graph this if we're able. Don't restart, that would be bad. If we're able to. We're able to figure out the rule without graphing it, we don't need to. So this tells me plus 5, plus 5, plus 5, plus 5, plus 5, plus 5. When, got an idea what our rule is for the y equals for part A here?
Y equals 5.
5.
5x plus -2.
So I can either write it like that, or we could write it y equals 5x minus 2. Now yes, thank you, George. I am very much a fan of plus the negative, because we are used to the equation being in y equals mx plus b form, and it's easier to see that b is a -2 here. So if I start graphing, I put my first point at -2 on the y-axis, and then it would go up very steep because my slope is a 5. Bigger the number you have here, steeper it is. So think about, like, if you're going skiing, a slope of 1 to 1 is a nice 45-degree angle. A slope of 2 or a slope of 3 or a slope of 4 or 5, or like, you get very, very steep. And B, Mr. Wirtz, did you have time for B? So first off, let's identify our starting point. What's our start point? good to help you, Simon, or do I need to move on, like, pass to somebody else? Sorry, what was that? Teak, what is our starting point in BI? Ooh, careful. It's not when x is 1. It's when x is 0 is our starting point. So we don't look at figure 1. We actually look at figure 0. So our starting point here is 5. Then our growth here, do you want to give me the growth, Teak? Our growth is 2. So our equation becomes y equals, who can help me? Sorry. Thank you very much. 2x plus 5. So I know that's weird. We don't start at 1, right? We start at 0. That's our initial value. BII. Take a moment, double check your work there. Connor?
Negative 4x plus 7. Why?
You sure about that? I agree with the plus 7. Check your growth. Subtracting how much? Ah, so it's negative 3. I'm going to put that guy in parentheses because it makes things better. Negative 3 times x plus 7. You don't have to have it in parentheses, but the thing that often happens is kids write that down, and then they come back and they're like, y equals minus 3x. But what? What am I subtracting? Like, if you put it in parentheses, it's kind of easier for us to see. Questions on making those rules? Hey, Quinn and Simon, can we handle being in a group with each other, or are we just going to make faces all day long? So, I'm going to give you one more opportunity to act like 7th graders, and then I'm going to move both of you, okay? We're not in here to have a foot battle or shove each other's desks or take each other's, like, we're in here to learn. If you can't figure that out, either move yourself or let's go have a conversation somewhere. So if you can't sit where you're sitting, that's your choice right now. I'm kind of experimenting with letting you guys choose your own groups. I don't know, I'm kind of on the fence right now. What? Oh, yeah, right? Is it like, once you get the skill, once you get this strategy down, it's pretty straightforward. All right, so now we have the rule. Now we're given the pattern, and we need to make a table or something that makes this happen. So draw figures 0, 1, 2, and 3. So you had this in your homework. I helped somebody, and I forget if I still have it. I made a little robot out of tiles. I think I recycled it, though. All you're trying to do when it says draw a pattern is something that would describe it. So what does the pattern in A start with? Anybody? 3, right? What's it grow by? 4. So if I want to draw this, I can start maybe with 3 like this. And maybe my growth of 4 then makes figure 2. You don't have to copy me. So here's my, or sorry, not figure 2, but figure 1. So here's figure 0. Here's figure 1, but I need to put my growth on. So I don't know, maybe 1, 2, 3, 4. I don't know. You can make it whatever you want. If you have a better, like more, something that looks better, you could do that. Now, I could go as straightforward as a 3 stack. And then for figure 1, I just put on a 4 stack. For figure 2, I put on another 4 stack. Sorry, that should be same width. That kind of looks off. Crap, I want that to be a different color. Smartboard struggles. Put on another 4 stack, and again, that's too wide. My next figure, I put on another 4 stack. Like, you can do whatever you want. That would probably be the easiest way to show that pattern. Does that still make sense? I don't want to keep spending time on this if we don't need to. Like, drawing it out is just kind of however you visualize it. Braylon? No, just figure out how to ask it, but ask it. Well, I can wait. Okay.
I figured it out just now.
Okay. Did you figure out that you have a question? Just let me know. We'll just do this through conversation. In 35, it says invent 2 different tile patterns that both have growth of 4, but yet are different. How could we? Say it louder, Savannah.
They have different starting at 0.
You could have different starting points, right? So if you want 2 different growth by 4, that like same growth, but they have to be different, start somewhere different. Maybe one of them starts at 0, one of them starts at 2. Or what? I mean, it doesn't matter. One of them could start at 0, and one of them could start at 8,740. Now that would be hard to draw, but you could. You could do it, right? Any other questions about y equals mx plus b? If you want to know the technical name for this, that is the linear equation. It's the parent function of linear equations. We really start with the most easy type of linear functions, being just y equals mx. If there's no b, that means we start at 0. So if there's no b, what that means is it's still a linear equation. It's still everything we just talked about. But its starting point is at an intersection of 0, 0, or at that origin point, as opposed to being somewhere else. And this would probably have a slope of 1. It looks very even as it goes up. Compare everything to, well, and this is kind of dangerous, your stairs in your house. Actually, part of your homework. I always debate whether to do this or not. You don't have to do this, but most people, when we talk about stair steps, if we talk about a stair step on graph paper, like if I look at my smartboard, if I stair step up my graph paper, what slope will that give us if I stair step up my graph paper? So let's say we start at the origin. I'm going to go real thick so you guys can see. And I stair step. So if I make that a line, right? Those are my points, but I just wanted to draw it like stairs. What's your slope there? 1, right? Because if I go up 5, I go over 5. I go up 10, I go over 10. Up 740, over 740. I'll make this kind of worth exemplary on the test. And I'll have to notate this somehow. When you're at home tonight, if you have stairs, I get it, if you live in a ranch or whatever, you might not have stairs. If you have stairs at your house, I want you to measure how high is each step. How do I get back here? So how high your rise on the step. Actually, that's literally on stairs called the riser. The riser is the thing that it's also called a kick plate. So if you're going up the stairs and you stub your toe, you hit the kick plate or the riser. And then the tread is your run. So if you have to replace stairs or build stairs, those are treads because you tread on them, right? It makes sense. We name things to make sense. So if you measure both of those, we can figure out the slope of your stairs. I guarantee not everyone's house is the same. If your house is built for older people, like maybe an old couple built it originally and then they sold it and whatever, your stairs will probably have a lesser slope because it's hard to like pick your feet up really high. If your house needs to be like really tall and you got to get up like a really high, like you have high ceilings in your first floor or whatever, your stairs are going to be a bit more steep, a bit more angled up. Yeah. And then if you like climb a ladder to get upstairs, well, that's really steep. All right, with that, we have a little over 10 minutes left. Work on your homework, guys. If you've already done 4 and 4, you can go ahead and start looking at 4 and 5.
Wait, will we just get a forward?
Or tape measure or what, like, yeah. Yeah, so how high up from stair to stair, and then how long across the tread. That's it.
We do that tomorrow.
Well, and then you got to do a tell me the slope. Now, here's the other thing, and you guys are trying to like be starting your homework and everything else. Let's say I went home and I measured, I hate to say this, but you're probably going to need to do this in inches, just because if you have you could do millimeters or whatever, but I'm going to talk about this in inches. A standard, I don't know, I'm going to make this up. But let's say it's 8 compared to 12. My risers are 12 inches deep. They're a foot. Right, so I got to fit my feet on them. I'm guessing it's probably close to a foot. And it's only 8 inches tall. That slope becomes 8 over 12. We can talk about slope as a decimal. This is 2/3 though, and it becomes 0.6 repeating. It's not a nice, actually I kind of think that's a nice decimal. But what we do when we put slope as decimals is then we can compare things more easily. So if Jessica comes back and tells me her slope is actually like a 0.85, and I know mine's a 0.6, I know her stairs are steeper than mine. Now if somebody comes and tells me their stairs have a slope of 2, I highly doubt that. Because that means you're going up 2 feet every time you only go 1. Like, that'd be really awkward. And if you tell me like your stairs have a slope of like, I don't know, 4, let's imagine this. If your house had stairs with slope 4, that would mean you go up 4 over 1. That would be like climbing stairs like this. Yeah, no, you're not going to have a stairway like that, right? Like that doesn't make any sense. So always think through, does it make sense? Now 1/4, if I flip it, 1/4 would be like, okay, do your homework. I'll stop talking. Slope 0 is this. I'm on a slope 0 right now. Oh, this is flat. Earth isn't flat, but when they pour this, it levels.
Yeah, they have little level feet.
Mhm. You want to know how people... Okay, so I'll show you some add-on stuff. Why do I hear people drumming? So check this out. With talking about slope, I've never watched this, so I hope it's decent. When talking about slope, I used to landscape. So you can do your homework if you want. You can ignore me. But this is a tool that we used to use called a laser level. I have no idea who this guy is. He's like making a wall or something. So you literally have a laser on a tripod. And it spins. And you attach a device at a very specific spot marked on this is like a giant vertical ruler. And you attach essentially a laser receiver to this thing to be able to compare. Your laser becomes your flat line. And you can check, see that's his laser receiver right there. So your laser's perfectly flat. And you like set it up to be perfectly flat. Then you can compare everything just using the laser as you go out and out and out and out. And you change the slope or try to keep it flat. And you can hear it too. Oh, it's fine. So that buzzing, yeah, I mean, it's not copyright or anything. That buzzing that he heard was telling him he was like on the right spot. So this is like we would tamp gravel, and your gravel has to be at an exact height so that then you put down a really thin layer of sand and then you put your bricks on top of it. And it all has to be perfect. I mean, it's just some dude posting, like, he's got 1,000 views. But actually, for me, contributing, like, hey, go subscribe to Pave Tool Innovators. I'm sure he doesn't. Yeah. What? Okay. If you want on my YouTube video, now's your chance.
Hi, world.
Hi.
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 And